Hello everyone, and welcome to the 4th devlog of my game, Dungeon Mayor, a roguelike city building game. One of the things I've spent a lot of time on is the terrain, as you could have seen in the previous devlogs. I have completely stepped away from the tile-based generation and started work on a new system, which I call pixel-based generation. Every pixel on the terrain is generated. In this part of the video, I will explain how I generate all those pixels. Before I explain the terrain system, I quickly want to tell you that I have a Discord server. I will leave a link to that in the description. If you have any questions or if you just want to hang out, show your own game dev related things, feel free to join. And I also have a Twitch channel now, so maybe I will stream on that. I currently don't really know. Yeah, that's just what I wanted to tell you before we start this video, so enjoy the rest of the video. First of all, I use the chunk system. This allows me to only generate terrain around the player. So wherever the player goes, new terrain is generated and old terrain gets deleted. This is a very common way of doing open world, since it limits itself to only a few chunks instead of creating the whole world. This keeps the memory in RAM low, thus it does not stutter as much. After the chunk system, I need to generate some visuals, because just white is a bit boring. My generation uses a mix of Perlin noise, rich noise, and simplex noise. Before continuing, it might be a good idea to tell you this is generated on a compute shader. This is a bit of code that runs on the GPU instead of the CPU. If I would generate it all on the CPU, the game would stutter immensely to a point that it wouldn't be fun to play. When it runs on the GPU, firstly it is generated way faster, secondly the CPU doesn't experience as much stutter. The very first thing I do within the compute shader is generate a big Voronoi pattern. This will control what biome family is used. A biome family is basically just an array of biomes, and in the next Voronoi pattern I choose that biome. The next Voronoi pattern is a bit smaller and it goes inside of the bigger ones. This will contain a specific biome inside that biome family. For example, a cold biome family will have all the cold biomes like snow, ice, or rocky biomes. When the generation needs to generate a cold family based on the big Voronoi, it can select a biome from the family with the smaller Voronoi. Of course, just plain colors will not be that interesting, so I have to add some textures to it. This is actually more tricky than you might think, since I cannot just add a bunch of textures to it and hope for the best. In order for the compute shader to work the most optimized, I have to supply just one texture. This means I have to combine all of the biome's textures into one big texture. This is very easy. The hard part is for the compute shader to know where each biome's texture is. I supply the shader with 4 arrays. The first array contains all of the texture coordinates for every biome. And the second array contains information about the families. The third array helps the second array, since it contains the start index of the family as well as the amount of biomes in that family. This allows me to add any number of arrays with no fixed size to the compute shader. The fourth array basically contains a two-dimensional array, which helps to index the families based on humidity and temperature. I hope the visualization gives enough explanation on the topic. I don't want to be too technical with my devlogs, but some explanation of programming will still be given. If you have any questions about the programming or my explanation about these arrays, feel free to ask me in the comments or on the Discord server. Currently, the terrain looks a bit boring. The Voronoi gives some pattern, but the edges are just too sharp. In order to break the pattern into a better looking transition and a more interesting shape, I use a version of simplex noise to offset the sample positions. That is almost the texture side of the generation done. The only thing missing now is rivers. For this, I use ridge noise. Ridge noise is basically the same as Perlin or simplex noise, but instead of it being between the values of 0 and 1, I multiply it by 2 and subtract 1, and then I get a value between -1 and 1. With these values, I can then get the absolute value and then get ridge noise. It is that simple. By tweaking some of the values, I get rivers flowing through the terrain. Just rivers is a bit boring, so by making the rivers a bit wider, this is how I do it, I can get the riverbed. This is just the area surrounding and in the river, just like the sand besides the river. Instead of only using sand, I also added a riverbed parameter to the biome section. So instead of just giving only the coordinates for the biome texture, it also gives the coordinates for the riverbed texture. This allows for different riverbeds, like stone in the desert. To close things off for the biomes, I just added weights to them. This way a family can generate certain biomes more often than others. Inside the desert family, I want a lot of sand, but to break the pattern, I want a bit of stone. So by using the weights, I can do that now. That was all of the texture stuff done. If you want a full recap, I will link some documentation I used below. Of course, I also want some items to spawn on the terrain. So in order to do that, I generate a list of positions for items to spawn on, and I add information such as the biome and a random value that can be used for other stuff. For example, to select an item to spawn. This spawning system is far from complete, as I can use a object pool to temporarily store objects when they are not used and enable them when they're used. This is an optimization that needs to be done in the future, but for now it's okay. This terrain is still not done, as I have some ideas to improve it, but for now I want to focus on other important parts of the game. Because the game is not just about the terrain. Again, if you want to know more about terrain or if you have questions about the game in general, don't be shy, comment on the video, tweet me on Twitter, or join the Discord and ask whatever you want. To give a small glimpse of what I'm currently working on, I am working on the inventory and everything that has to do with items. This means that I have to set up a very simple combat system to test all the combat items. I will have to set up simple crafting system to test crafting. And I have to give the player some stats, like health, stamina, and other stuff, to test the consumables. What you're currently seeing is the first pass of the inventory system and its items. It might take a little bit longer because I also want to make custom inspector windows for them, since that will help me later on, when I just want to add items or crafting recipes. I have currently made a very simple inspector for all the item objects, just to test what I can do. I've also made a custom attribute. This allows me to just add something in code above a parameter and it will change the appearance in Unity. For now I made a bar attribute. This will showcase a bar, which can change its size, like a health bar. This again was just to test what it does, but it also adds some cool way to give me visualization on parameters, like health or stamina. I hope the wait for the next devlog will be a bit shorter, but due to the graduation and other college assessments, development for Dungeon Mayor is a bit slow. I want to give weekly updates, but currently I can't. This is the end of this devlog. If you have any questions, you can always ask me on social media. You can follow me on Twitter, Twitch, or you can join my Discord server, the hub for all Dungeon Mayor updates. You can also join and show your own game or own game dev projects. Let's just have some game dev fun together. I hope you liked this devlog. I am not sure when the next one will be, but I can already promise it will be a good one. And I have to give the player some stats, like stealth, stealth? Since, whoa.